You are standing on Kepler 186f, the reddish soil crunching underfoot, a perpetual twilight painting the sky a deep, unsettling crimson. Your breath catches, not from cold, but from the sudden, profound realization that this alien world, 500 light-years away, could be humanity's next true home. This isn't science fiction anymore. It's the potential future unfolding before your eyes. The very air, if you could breathe it directly, would taste foreign, a mix of possibilities and peril. Kepler 186f is no Earth twin, but rather an Earth cousin, slightly larger than our own planet, with a radius about 1.1 times that of Earth. If its composition mirrors Earth's, its mass could be around 1.44 times ours, meaning you'd feel about 17% more gravity pulling you down, making every step a little heavier. This increased gravitational pull is actually a good sign, potentially helping the planet hold on to a denser atmosphere, vital for supporting liquid water and ultimately life. The sky above is dominated by a red dwarf star, Kepler 186, smaller and cooler than our Sun, casting a muted, reddish glow that makes even midday feel like an eternal sunset. This star, only about half the mass of our Sun, gives off significantly less energy, meaning Kepler 186f receives only about 32% of the light Earth gets. Yet it orbits much closer, completing a year in a mere 130 Earth days. This tight orbit means that while the light is dimmer, it's still within the star's habitable zone, that crucial region where liquid water might exist on the surface. The first stark reality of life on Kepler 186f is the light itself. Everything is bathed in hues of orange and red, a constant reminder of its dim, red dwarf sun. This isn't just an aesthetic shift, it's a biological challenge. Earth's plants, accustomed to a broader spectrum of light, especially blue and red, might struggle. Photosynthesis, the engine of life as we know it, would need to adapt. Perhaps the native flora, if any exists, would appear black or deep purple, having evolved to absorb every precious photon from the red-heavy spectrum. Imagine forests of dark, almost black alien trees stretching towards a perpetually dim red sun. Our own crops would need genetic modification or specialized indoor farms utilizing artificial full-spectrum lighting to thrive. This fundamental difference in illumination would cascade through the entire ecosystem, demanding ingenuity and relentless adaptation from any human settlers. Then there's the atmosphere. While Kepler 186f is Earth-sized, its atmospheric composition is currently unknown. Computer models suggest it could have a substantial atmosphere, possibly even containing oxygen, but this remains pure speculation without direct observation. If it's too thin, radiation from the red dwarf could strip it away over cosmic timescales. Red dwarfs, despite their longevity, are known for unpredictable and powerful stellar flares. Without a robust atmosphere or a strong magnetic field, these flares could pose a constant, deadly threat, bathing the surface in radiation far beyond anything Earth experiences. Even with an atmosphere, creating a breathable environment would be a monumental undertaking. Terraforming, the ultimate cosmic DIY project, would involve introducing specific gases, perhaps even through engineered microbes or plants, to create a suitable mix of oxygen and nitrogen. This isn't a quick fix, it's a centuries-long, multi-generational endeavor. The gravity, approximately 1.17 times that of Earth, presents its own unique set of physiological challenges and benefits. While not drastically higher, a constant increased pull would subtly yet profoundly reshape human bodies over generations. Bones might become denser, muscles stronger, but circulation systems could be stressed. Artificial gravity habitats during the journey, or specialized exercise regimes on the surface would be crucial to mitigate these effects. Conversely, stronger gravity helps a planet retain its atmosphere and oceans, a vital factor for habitability. The planet's axial tilt is likely very stable, similar to Earth's, suggesting the possibility of regular seasons. However, because Kepler 186f orbits its star in just 130 days, these seasons would pass much faster than on Earth, potentially creating rapid environmental shifts that living organisms would need to navigate. Water, the elixir of life, is theoretically possible on Kepler 186f due to its position in the habitable zone. However, being at the outer edge of this zone, surface water could exist primarily as ice, a frozen world waiting for human intervention. Thawing vast reserves of ice would require immense amounts of energy, perhaps through engineered greenhouse gases to trap heat, or even orbital mirrors to increase sunlight exposure. If surface water is scarce, colonists might need to import water ice from other celestial bodies within the system, or chemically synthesize it. But if liquid water is abundant, orange oceans under a red sky would transform the landscape, creating entirely new marine ecosystems waiting to be explored, or perhaps seeded with Earth life. The journey to Kepler 186f is a monumental hurdle, a terrifying 500 light-year voyage. Current technology is nowhere near capable of such a feat. Even with advanced propulsion systems reaching just 20% of the speed of light, the journey would still take over 2,500 years. This isn't a trip, it's a multi-generational odyssey. Imagine generations born and dying aboard a colossal starship, never seeing a planet other than the one they are leaving or the one they are heading towards. Cryosleep, if perfected, could reduce the perceived travel time for the original crew, but the logistical and psychological toll of such an interstellar migration remains almost unimaginable. The sheer isolation, the cosmic emptiness, the fragility of a small vessel carrying the hopes of humanity across an unimaginable void. These are challenges that transcend engineering. Upon arrival, the immediate necessity is creating shelters capable of withstanding the alien environment. Underground bases, shielded domes, or even cloud cities suspended in a dense atmosphere are possibilities. These habitats must protect against radiation, maintain breathable air, regulate temperature, and provide a psychological anchor in an utterly foreign landscape. Resource extraction would be critical. Mining local regolith for building materials, extracting water from subsurface ice or atmospheric moisture, and establishing closed-loop life support systems for recycling air and water are fundamental. This isn't just about survival. It's about building an entirely new civilization from scratch, millions of miles from any form of established support. Agriculture on Kepler 186f demands revolutionary approaches. Earth plants, optimized for our sun's spectrum, would need significant bioengineering to thrive under a red dwarf. Perhaps new photosynthesis pathways would be discovered or engineered, allowing crops to efficiently utilize the red heavy light, possibly leading to purple, black, or even yellow-leaved plants. Vertical farms, hydroponics, or aeroponics within climate-controlled environments would likely be the initial norm, slowly transitioning to outdoor agriculture as terraforming progresses. The challenge isn't just growing food, it's creating a sustainable, self-sufficient food system in an alien biome.
The ultimate goal of colonizing Kepler 186f isn't merely survival, but human flourishing. How would human physiology adapt to higher gravity, a red-shifted world, and a faster orbital period? Over millennia, would new genetic traits emerge, akin to human adaptations to high altitudes or extreme climates on Earth? Our sense of time, our circadian rhythms, even our very perception of color and light could fundamentally shift. A new culture, detached from Earth's history and traditions, would inevitably arise, shaped by the unique conditions of their crimson home. What would art look like on a world where green is rare? What stories would they tell under a red sun? The biggest unknown is the presence of existing life. If Kepler 186f already harbors even microbial life, our arrival presents profound ethical dilemmas. Do we have the right to terraform a world that is already alive? Our intervention could irrevocably alter or destroy an alien ecosystem, a cosmic tragedy we might not even fully comprehend. The search for exoplanetary magnetic fields is crucial because such fields protect planetary atmospheres, which is key for life. While Kepler 186's magnetic field status is unknown, planets orbiting close to small stars are thought to likely have magnetic fields. However, some research suggests that a magnetic field doesn't always guarantee protection against atmospheric escape. Kepler 186f is more than just a distant rock. It's a mirror reflecting our deepest desires and greatest fears for the future. It's a testament to our insatiable drive to explore, to expand, to survive. The idea of humanity's next home being Kepler 186f forces us to confront the limits of our technology, the resilience of our biology, and the very definition of what it means to be human in a vast, indifferent cosmos. It's a gamble of epic proportions, a journey not for the faint of heart, but one that promises the ultimate reward, the continuation of our species among the stars. The faint reddish light of its star, a beacon across 500 light-years, whispers of a future that is both terrifyingly challenging and breathtakingly possible. It beckons us to evolve, to invent, to dream beyond the confines of our pale blue dot towards a crimson dawn on another world.